We're back, and I'm actually going to be back with Scott Roberts, who is going to be introducing Dan Scrolsler. Is that right?
Scoff. Not Scoffler, but Scoff. Skoff. He
Oh,
is.
Scoff.
Yeah,
Dan Scoff. Okay, I'll
I,
get the name right. I am terrible with names. I remember faces like there's no
I
tomorrow.
do. I probably can't even really remember your name, uh, Sean.
Some guy that just is
Some
on the
guy over
video.
there.
So what I'm going to do is I'm going to let Scott introduce this, and then we're going to get this video up and running.
Wonderful.
Scott, it's all you.
Okay, guys. Really happy to be here with Woodland Hills Camera and Telescope and doing the celebrating. It's Astronomy Day. Yay! It's like Christmas and New Year's and everything rolled into one for astronomers. So it's fantastic. And it's a beautiful day here in Springdale, Arkansas, where I'm broadcasting from. Okay. But also in Northwest Arkansas, in this little Northwest corner, we get some severe weather. Okay. And this has attracted a lot of storm chasers, meteorologists, tornado chasers, that kind of thing. And one of these tornado chasers and storm chasers is Dan Scoff. Dan, his story was as a young boy, he said he would often climb the upper floor or sometimes the roof of his house to watch approaching storms. His parents would let him do this. So I think that's kind of crazy. But, his family is dashing for the basement, and I've been in a tornado, so I know, how crazy it can be. But at 8 years old, he knew that he was going to make a living as a meteorologist. Okay, so these experiences were the catalyst for this guy, and he has been from all the way through Tornado Alley, Oklahoma on up. Okay, chasing tornadoes, chasing storms, advising people on how to be safe. And he loves it. And he is revered amongst storm chasers and other meteorologists for his knowledge of how to predict weather. And for us, I asked Dan to put this together to teach astronomers how to predict cloud patterns. Why is that important? Well, if you're an eclipse chaser, this is really critical. This could make or break whether or not you see an eclipse from where you plan to go. It also helps you make contingency plans. You still want to make your observation. You can, there are things called microclimates, where you could race off to maybe another area where you have a better chance. So, and that is in fact what Dan Scoff did for the 2017 eclipse. He had picked this one place, had predicted way out in advance that it would be good, and it wasn't good. Things change, but he was able on the fly to get to clear weather so he could see the eclipse. So anyways, I will turn this over to Dan from KNWA television here in Northwest Arkansas.
Hi everyone, my name is Dan Scoff. I'm the chief meteorologist of KNWA and Fox 24. And a good friend of mine, Scott Roberts with Explore Scientific, came to me and said, what would be cool if you do a demonstration on how you predict cloud cover. Now, this is obviously not an exact science because forecasting the weather, you use computer models, and I'll go into that and explain that. But it's very important to know what type of cloud cover is coming in, how much cloud cover you're expecting, and at what time. And so I wanted to provide a little demonstration, if you will, a little presentation on how to predict cloud cover, and that's exactly what we're going to be doing here. I'm going to take you through some quick and easy ways to predict cloud cover. And I'm also going to show you some ways that you can do it on your own with computer modeling. And I'm going to take you through some of the different computer models and the computer model products and give you a little bit better understanding on what to expect. And so first of all, when we take a look at predicting cloud cover, there's a couple things. This is a very basic understanding of clouds and the different types of clouds. We're not really going to go into the details of the different types of clouds, the elevations, all that stuff. But we are going to look at several things. And so first of all, this is one of the things that I think is the best way to make a forecast. This is looking out the window. So what do I mean by that? Well, I never start a forecast before I look out the window. And I don't want to make a forecast until I realize what's actually happening. So when I say look out the window, I'm talking about look at the current conditions, see how that matches up with the satellite imagery, and then also see how that matches up with the computer model analysis. So that's what I mean by looking out the window. And we have some great tools as meteorologists that we can use to look out the window, such as analyzing satellite products. And satellite, the technology has gotten excellent. And we're going to go through some of that. And I'm going to show you some of the ways that you can use this satellite technology, as I'll show you what I have on my webpage, and you can bring this up as well. These are free websites that you can use. So check that Visible Satellite. Now, Visible Satellite is a product that only works during the daytime, which obviously isn't helpful for an astronomer trying to predict cloud cover at night, but it'll give you an idea at what's coming in and some of the weather systems. And we're also going to take a look at using computer models to predict clouds. Now, we'll go over that a little bit more in just a bit. But you have to understand, and I'm sure as a lot of astronomers understand coordinated universal time, Zulu time, Greenwich Mean Time. All of those are really important to understand basically what time you're looking at, because that's how the computer models are done. And so I'm not going to go through this in detail, but I'll just tell you this. Midnight in England, Greenwich Mean Time, is 0Z. So 0Z essentially could be 2,400 hours in military time, even though it transfers to 0Z, 100 hours is essentially midnight. But for the different time zones, especially with daylight saving time, if you're on the East Coast, you take that Greenwich Mean Time and you subtract it by 4. Central Daylight Time, you subtract that by 5. And for the West Coast, Pacific Time, you're going to subtract that by 7. This is only during daylight saving time. So hopefully you know how to do the conversion for universal time code, because that's what you'll be seeing with these computer models. So for instance, I have 100 hours, which is midnight, the new day off in England. I'm subtracting 5 for Central Daylight Time. So if I take 2,400 minus 5, then you get 1,900. Well, when you take 1,900 hours in military time to convert that to AM, PM, well, you're going to subtract 12, and that gives you 7. And you know 1,900 is obviously not 7 in the morning, it's 7 at night. So we have 7 o'clock in the evening, PM, Central Daylight Time, if it's 0Z in Greenwich Mean Time or Universal Time Code. And so that's just a real quick basic understanding. We're also going to show you how to use the National Weather Service to predict cloud cover percentage. But before I do that, I want to get into that satellite imagery and show you what I'm talking about. So this is a great website, and I'll give you that website again at the end. It's weather.cod.edu. This is going to show you a lot about the clouds and the different types of clouds moving in. And so how does this work? Well, you're going to go to Weather Analysis Tools. You're going to click on Satellite and Radar, and it brings up this, which is awesome. It's a high resolution, what we call GO16 satellite imagery. You can loop it by hitting the play button, and you can see how the clouds are evolving. Now you can also get fine details as you zoom way in, and that'll show you a little bit more about what's happening very locally. But there are different products that you can use on the left-hand side of your screen. You can use the visible blue channel. You can use the visible red channel. Now, blue channel will show you a little bit more of the different features of the land, but you're really more interested in predicting these clouds. You can also look at what's called water vapor. Now, water vapor isn't really going to show you clouds, but you'll see that there's water vapor everywhere, so you can see weather systems. This is a great way to predict weather systems. Probably the most important for you will be essentially a cloud phase. So this will show you what type of different clouds. Now, here's another great example of what we call nighttime microphysics. And so even at night, you'll be able to see clouds moving in. Now, keep in mind, this is during the daytime, but I will show you an example at night. And so we're going to go to a different continental sector. You're going to go to the west, because this goes west. Now this is an area that has already seen, that still sees darkness. In fact, you can see that taking place. So let me go to the visible, and you're going to see this visible sweeping from east to west, and that's obviously the sunrise. There's all the storms, and there's the cloud cover. But notice if I stop this here, it's dark. There's literally no daylight lighting up the clouds. So what you have to do is go to that nighttime microphysics, and now you can see those clouds even at night. So that is going to be very useful for you to see clouds that are moving in. Finally, another thing too, as I get back to my sector, we're going to go to continental sectors. I'm going to go to goes east, and since we have sunlight, if you're doing a short range forecast, you can look at cirrus clouds. This will show you exactly where the cirrus are. And we know as astronomers, and I'm an amateur astronomer, definitely not a professional, high cirrus clouds can wreck any type of celestial viewing, whether that would be a meteor shower or looking at the planets or the moon. I mean, high clouds can really wreck it. And so this will give you an idea of the cirrus clouds. Finally, we can look at regional sectors and zoom in. You can get a lot more detailed, and these update every 5 minutes. Sometimes you can get mesosector, which is essentially updating all the time, every minute, and sometimes even as much as every half minute, so every 30 seconds. But that's a look at some of the images that you can look at. Now, of course, this is only good for what's happening right now, and that's what I mean by looking out the window. So to go back to that site and to let you know where that was, I'm going to show you. I'm going to bring that up here as we take a look. weather.cod.edu/SatRad. That's going to be your site and the go-to for looking out the window. Now I'm going to give you a real easy way to predict cloud cover just by, if you don't want to look at computer models, you just want to kind of get a forecast, we can look at the National Weather Service tabular grids or the hourly forecast. And so I'll take you through this as we look at the tabular grids. So this is a quick and easy way using the NWS products, and I'll go into that here in just a bit. Weather.gov is going to be your site. That's going to be the easiest place to get that. And we're going to use tabular forecasts with point forecast information. The good news is that this will be available for anywhere you want to go. It gives an hourly cloud percentage coverage up to 5 days out. So that's going to be very useful for forecasting short range forecasts essentially, and what we would say medium range. Now it also gives hourly forecast information as well with the gridded information. And so that will be very useful there. Let me give you an example of this as we go to our website, and I'm going to bring up the National Weather Service. So the National Weather Service gives great forecasts. I'm going to give you my area because I know we're expecting cloud cover. On the day this is recorded, there's a big storm system coming in that will likely bring severe weather across parts of our area on the following day. And so we know the cloud cover is going to be increasing. So here is a look at this point forecast. Now you can click on this. You get your local local weather forecast office just by clicking on the map where you live. And essentially, I'm going to show you in Northwest Arkansas, where I reside. We're going to go down here to the point forecast. You're going to click on wherever you live, Fayetteville, and then you're going to notice a forecast. Now, this gives cloudy, and it shows clouds, and it doesn't really give you a real detailed information on the cloud cover. So we're going to go down here, click on tabular forecast, and this will give you right here sky cover percentage. And so you can see that sky cover percentage going up in percent as the next storm system moves in, and it gets all the way up to 98%, by the way, if you can see that on the screen. So this is 84, 91, 90. Now, the great thing about this is this goes out 5 days, so you can start any time that you want with this tabular forecast data. I like to typically start at midnight, and then there you can see the full day. Now you forward 2 days, and you can look at that cloud cover. Also, if you don't want to get all of this stuff, you can literally come in here, you can check on and off on these different things, and of course it's all useful, it's all helpful if you want to forecast rain. This is not just forecasting clouds, but this will kind of remove some of the extra stuff, and then you can see sky cover. But it's just fine to load it up, in my opinion, altogether. And so again, that will go out 5 days out in advance. So you can see that we're going all the way to Friday, and you can see some cloud cover on the 24th of April, the 25th, there's cloud cover. we go back a few days, and you can see that we definitely have some active weather coming our way with multiple chances for rain and thunderstorms, and that obviously will lead to a lot of cloud cover. We go to submit here, and you'll see an ending time to our cloud cover forecast on the 26th. All right, so that's a quick way. Now there's also another way too, as you saw with the hourly weather graph. So we'll go back on this, and if you like a line graph to kind of display, that's a little bit easier. You go to the hourly weather forecast. And so this will show you right here on this blue line, sky cover. And so you can see the amount of sky cover that you have, and you can see how this storm system coming in. Well, 7 to 1 o'clock. Now, keep in mind, this is not Z time. This is local time, so you don't have to convert anything from Z time, but you will when we're looking at computer models. And so there's a look at the cloud cover that's across the region. And then there is an example of that in a tabular forecast. So essentially the same data, but very useful and a quick, easy way to get that information out. And to predict. Now, that only goes out 5 days, so hourly forecast information, very useful, but that only goes out 5 days. Now we're going to take a look at computer models and computer model forecasting. And so computer model forecasting, very, very useful for forecasting farther out in advance, and sometimes even short range. Now, it's basically an art to forecast off of computer models. And there are many different computer models that are out there, and some are better than others. And some have their limitations, and others you won't find the products for clouds on free sites. So some of the models you have to pay for. Some of these high-end computer model websites, you have to pay for a subscription service. And if that's worth it to you, then a great thing that you can do. I have several subscription sites for computer models. Now, keep in mind that higher resolution models offer the best small scale features or the small scale details. And this is important for thunderstorm development. This is important for some type of small scale feature. Let's say a big thunderstorm complex moves through, it develops a low pressure system, and that in turn ends up building up more cloud cover. So those are mesoscale models. Now, higher resolution means that you have more grid points. Think of the way on a TV screen. You have 4K, you have more pixels on the TV screen, you have higher definition, you have a more complete, detailed picture. At the same time, though, that higher resolution computer model does require more computing power. And because the computing power is more, the times of these models in advance don't go out that far. For instance, when you're looking at some of the mesoscale models, the HRRR, known as the HRRR, or the High Resolution Rapid Refresh model. Now this forecast is updated hourly, which is great for forecasting storms and severe weather. It only goes out 18 hours. So when you're trying to look for a forecast, the following night, that's not going to help you. Now there is the extended HRRR, which is updated 4 times a day, and there's that Z time again. So 6Z is essentially 1 o'clock in the morning, Central Daylight Time. 12Z would be 7 o'clock in the morning, Central Daylight Time. And 18Z is 1 o'clock, and 0Z is 7 o'clock in the evening. And again, that's all Central Time. You can convert it to your time zone. The NAM 3 kilometer goes out 60 hours. So now we're getting a little farther out where you can get at least 2.5 days and pretty close to 3 days. And then you got the NAM 12 kilometer. I'm going to show you the difference between the resolutions and how lower resolution computer models essentially lose the details. And when you're forecasting thunderstorms and high clouds from thunderstorms, like we were for the August 21st, 2017 great solar eclipse that went across the United States, there were storms that popped up in Kansas City, and that cirrus deck was coming over my observation area in central Missouri. So that was a whole nother nightmare. We won't get into that. But synoptic scale models, they're long-range models. So if you're predicting a night sky viewing for 10 to 14 days out, then you want to look at those long-range computer models. The GFS model, known as the Global Forecast System. This is an American-made model. It goes up to 16 days out. Keep in mind, though, there is lots of error with the speed of these systems, the strength of the systems, so there's definitely some issues there when you're talking about the GFS. Not all computer models have their limitations and they're not perfect. And then you got the European model, 10 days out, better verification, but very, very hard to find free cloud percentage or free cloud cover products. So they're very hard to find. So let me take you through some free computer model sites, and this will give you an idea on what you can do to forecast the weather. So again, that Weather College of DuPage website, so useful. And we're going to go to that. And so when you bring up weather.cod.edu, you'll come to this home screen. And with this home screen, all you have to do is go to Weather Analysis Tools, and you go to Numerical Models. And you're going to notice that they've got different models up at the top. So remember that HRRR only goes out 18 hours, and it's updated every hour. And sometimes the full computer model is not in. So now you can click on your location where you live, and essentially if you're in Florida in the southeast, we'll click on this. Now this is for precipitation and wind speed and stuff like that, which might be useful for you. And you can see those storms moving into my area, into western Arkansas and the eastern Oklahoma area. But this is what you're going to want to use. You're going to want to use average cloud cover. And so this is a real easy way to look at average cloud cover. And there you can see right here as the clouds roll in. So notice Florida starts seeing some clouds, and now we're at Z time. So remember, 0Z is 7 o'clock in the evening, which would be 8 o'clock in the evening Eastern Daylight Time. So you got to remember Z time, because that's what everything is going to be in, all these computer models, and you just got to convert it to your time zone. Now you got cloud cover continuing to build. There might be some clearing over northern Florida early Wednesday morning as the storms kind of linger. But keep in mind, this is a computer model, and it might essentially not be perfect. Now, another thing you can use is what's called simulated echo tops, which will basically tell you if there's thunderstorms, and so that's kind of useful, but you're definitely going to want to use that average cloud cover. So now there's different models besides the HRRR. There's also the NAM or the NAM Nest. It's always best to go higher resolution, and so this is a 3-kilometer model, and we're going to zoom in here on the southeastern US. And now we're going to look at something called simulated infrared satellite. And honestly, I think this is one of the best cloud products that you're going to find. Now, you're only going to be able to go out 60 hours, but it gives you an idea exactly where these clouds are expected to be. And so let me go ahead and step through the time here. And you can use this slider bar, and there you see the cloud cover starting to build in. And then now you're going to notice that, so here is the forecast, which that one model did not have cloud cover, and there wasn't much cloud cover percentage. But now you can tell that you got these cold cloud tops that are coming over Florida early Thursday morning, and that might cause some issues in viewing. And so it might not be perfect. Now, there could be breaks in the clouds. So this is kind of a way to give you an estimate as to what type of clouds you're going to see. It's not perfect. It's a computer model, and it's not exactly accurate all the time, which is why forecasting is a difficult, non-exact science. But you'll notice that if I was forecasting a night sky view event over our area for Thursday morning, there's a pretty good chance that we'll be totally clear. And you can kind of see that. And if we go back to our surface products, and so each one of these different products offer different things. The different computer models offer different things. So that's weather.cod.edu. Again, you can go to that average cloud cover. You can bring up that. It's a little more coarser, but it gives you an idea of cloud cover. All right, so that's a good site there. I'll give you another good weather website, and we've got Pivotal Weather. So Pivotal Weather is a great site that will show you, again, that simulated reflectivity. We'll go to that, and I'll bring up that site, and you can get an idea for what you see with Pivotal Weather. So when you go to pivotalweather.com, you're going to go to forecasts, and you're going to go to models. Excuse me, not forecasts. You're going to go to models, and you're going to click on models, and this will give you an idea of what to expect. Now, personally, I like that slider feature where you can kind of slide back and forth. And so when we look at single image, we want to go to a forecast loop. Forecast loop is going to be your best friend. Let's say you want to zoom in a little bit more. So let's go and we're going to come into our zoom and we're going to pick regional. And you guys can play around with this and you can have fun looking at the different computer models. But a lot of amateur meteorologists, a lot of amateur astronomers do use these sites. So now on the left-hand side, you see all these different products and it can get a little overwhelming, but we're going to look at cloud cover. Again, this is what we're doing. We're forecasting clouds. It's a percentage from 0 to 100. And so we have a totally clear sky right now over our area and there's literally no clouds on the model. Now you'll see these clouds rolling back in. So remember that forecast for Thursday morning. And now look at what we've got. When we go to a lower resolution computer model, which we talked about, the GFS, now we've got a little more widespread and the cloud cover is not as detailed. Now I'm going to bring up some different models that you can look at. And we're going to go back to that mesosector, mesoscale, and we're going to go to mesoscale meteorology. And now look at the difference on those higher resolution computer models. But they don't go out as far, but they give you a better idea at some of the smaller scale features. So there's really great sites here. Simulated infrared. This is a very useful thing for the NAM 3 kilometer, which you saw on the College of DuPage. It's a very similar thing. But let's say you want to forecast even farther out. So you got to go to these long range models and you'll see them right here, the global. You got the GFS, you got the European. Now, when we go to the European, which is personally my favorite computer model, it has the best statistical verification, but you're not going to get clouds on this. And so unless you go to a paid site. And I've looked at many different sites out there and there's really no good cloud forecast products with the European. Finally, another one of my favorite sites, as I'm giving you kind of my top 3 computer model forecasting sites, is going to be Tropical Tidbits. And honestly, this might be your absolute favorite. So Tropical Tidbits is where you have very good satellite products, and it's also really easy to understand. So let's go to that site and I'll show you what we've got for Tropical Tidbits. So when you go to tropicaltidbits.com, it's not just for tropical weather. You're going to go under forecast models. It also has satellite imagery too, but I think College of DuPage is one of the best ones for that. Now we've got global, we got the GFS that it constantly loads, and you're going to pick up upper level dynamics. So you see this upper level dynamics. You can go to simulated IR for the satellite and look at what we have here. You've got cloud cover that's rolling in. There's the big giant storm. Look at that comma head cloud. So this shows you a really strong low pressure system that is coming through. But I'm going to show you the difference, and this is where it gets pretty awesome. I'm going to zoom in first of all on this, and down here you see regions. I click on that, I go to South Central, and you can see how that still has resolution, but if we go to mesoscale products and I go to a NAM 3 kilometer, now look at the difference. Now it's showing low clouds, which don't show up quite as well, but you can see the difference in the cloud cover. And so if you go to low cloud fraction, this is also important too, where now you've got a combination of clouds, but you can get more detailed. So now it shows that, hey, maybe we won't be as clear on Thursday morning as those clouds kind of stick around. Now for the Texas Panhandle on that morning of Thursday, that looks pretty good for viewing. But we still have these clouds that are sticking around most of the night into early morning. And that could be some fog too. So that's a great way to predict low clouds. And then finally, if I go to a longer range model, you're going to see how this, first of all, disappears. And that's because some of the models don't offer clouds and cloud types. And so that's a great example there. And so when we're clicking around here, you don't see anything with cloud cover, which is why it dropped off. So we want to go back to the NAM 3 kilometer, and we go back to upper dynamics, and you got high cloud fraction. Here's a simulated infrared. And again, you can kind of see the clouds and the low clouds if you loop it and move through. All right, so that's kind of a basic understanding at predicting cloud cover and looking at how clouds develop. And remember, it's always best to kind of look out the window. So let's do a quick recap here when we look at what we do to predict cloud cover. And so you always want to check satellite first to see what's actually happening. And that's what I mean by looking out the window. Looking out the window is probably the best way to predict cloud cover because you can actually see weather systems coming in. But it doesn't help you 5-10 days out when you're predicting weather events or astronomy events. Now you want to look at what's happening out the window on satellite, and for meteorologists, we compare that with the computer models analysis. What is it showing is happening right now compared to what is it predicting that's happening right now, which is what we call initialization. If you want to learn a quick way, you go to the tabular forecast data. You can enter in your location by city, and then you can bring up your tabular forecast or your hourly forecast, which is just a different way to display it. And computer models, they can be a great tool for forecasting the weather a long ways out. But remember, when you go longer out, they lack that resolution, and so sometimes it'll give you a convoluted, cloudy look, if you will, at what's happening, more than 7 days out. So forecasting the weather pretty much beyond 7 days is very difficult because these weather systems come off the west coast of the United States, and no computer model is going to get it right all the time. But that'll give you an idea as to how to predict cloud cover. So I hope you enjoyed. Happy sky watching, everyone. Enjoy the stars, and here's hoping for clear skies. So I hope you enjoyed that, and if you have any questions, you can direct them to Dark Sky, or you can direct them to Scott Roberts. He'll pass them along to me. But very useful tools, the satellite, the models, as well as looking at that tabular forecast. So my name is Dan Scoff, Chief Meteorologist of KNWA Fox 24. I hope you enjoyed this little tour on how to predict cloud cover.
We're back with Scott Roberts. Whichever direction he's in, he's down here probably for you lot.
Yeah.
And we are going to do a giveaway. Is that right?
That's right, Simon. So we have, I promised we'd do this with one of our 2-inch eyepieces, and it is turning out to be a 25 millimeter 100-degree eyepiece. Okay. Now, our eyepieces, we have over 40 different models, 7 different series. I have some eyepieces that I call our impossible eyepieces. Okay. This is one of them. I was told by a very knowledgeable person about eyepieces, actually not told directly, but kind of indirectly, that the longest focal length 2-inch 100-degree eyepiece would be a 22 millimeter. This is a 25, okay? So I just wanted to prove that we could do something that that was told that couldn't be done. And this is a fantastic eyepiece. It has about 14.5 millimeters of eye relief, 100-degree apparent field. It is like looking into a bay window out into space, and nice focal length as well. All of our eyepieces are gas purged. And the way that they actually test these things is they put them in a meter of water for half an hour, okay, to see if they leak. All right, because I warranty these eyepieces forever. That means if you buy one, you get one at Woodland Hills, you register it right away with us in customer service. You can do it online. And once it's registered, it's warranted forever, and it's a no-fault warranty. Now, what I didn't bring here, and I should have, is a melted eyepiece from the Paradise Fire up in California. The guy lost his entire house, lost all of his telescopes, lost everything. But he was able to return to me 2 melted eyepieces, okay? It looked terrible, and you can see how hot this fire was. Through no fault of his own, the eyepiece was destroyed. I replaced them, okay? That's the deal. So, if it's somehow damaged, you roll over it with a tank, I don't know. What the eyepiece.
Who's going to roll over it with a tank?
I think maybe now after this video, someone's going to find a tank so they can try it. Okay.
Oh my
They'll
gosh.
probably survive it because these things are built like a tank. Okay. They'll probably push into the ground. They'll get it out and go, damn.
So Scott Roberts will replace the eyepiece, but not the tank. Just to be clear.
Tank, yeah, your tank track might get destroyed and you'll owe them a pretty penny, but not so with us. Now, the other cool thing is that this is a transferable warranty. You know, amateur astronomers love to trade and trade up or trade across or whatever. They love to try different things. You know, we make, as I said, over 40 different eyepieces in 7 different series, and our series are all about the apparent field. And that ranges from 52 degrees, okay, which sell for under $80, all the way up to one of my other impossible eyepieces, which is this 9mm, 120 degree apparent field eyepiece. This is the world's widest field commercially produced eyepiece. 120 degrees means, what is 120 degrees? That means you put your hands out as far to the left and the right, pull them together while you're looking straight ahead so you can see your fingertips. That's how big the apparent field looks, okay? This eyepiece is a beautiful eyepiece, lots of magnification, tons of apparent field. It is wonderful for people that might have a big Dobsonian, because with more apparent field, you have more true field. Not only will you have that magnification, but you got more true field. So if you don't have a tracking system, okay, like on a big Dob, like a big 30 or something like that, or 20, the object's still going to be in the eyepiece for a long time, and it makes it easier to find the object when you're trying to center up. But it's at high magnification. It's a 9mm. Okay, so this is a lot of fun. One of the most fun eyepieces I've used. I just love it.
So
yes.
So the giveaway. This is how this one's going to work.
Okay.
And this is going to prove if you were paying attention. So we're not going to do a 1 through to whatever and say, I want to win. We're going to ask a trivia question.
Oh.
So here is the trivia question, and I want everybody to post their answer, and then Scott will pick a number between 1 and whatever. And here is the question.
Okay.
What color was the shirt Dan wearing?
What?
So the question again. The question again. What color was the shirt Dan was wearing?
Oh my God.
Put your answers in there. I will go through them, and then Scott will pick a random winner by giving a number 1 to whatever it would be. And he cannot see the chat, so he can't cheat either.
No, I'd like to, but
Give it away to, oh, look, Scott Roberts. Oh, there he is. Give it to him.
Yeah.
So
I win my own eyepiece? Yeah, great.
Exactly.
Yeah.
So what color was Dan's shirt? Start putting it in, okay? And you can enter more than once. So go. If you need a hint, it's 4 letters. And away it goes. All right, Scott, let's talk about other eyepieces.
Other eyepieces. Okay, so we talked about the 120, which is, I know I have to talk that way, but another really great eyepiece. I mean, I just love this eyepiece. This is the 30mm, 100-degree eyepiece, okay? Now we have a whole series of 100-degree eyepieces. We have 6 different focal lengths ranging from 5.5 millimeters up to this 30, this massive 3-inch, 7.5 pound. There's tons of glass in here, okay? But this eyepiece is the longest focal length, 100-degree apparent field, a hyper wide field eyepiece, okay? Again, you know, forever warranty, gas purse. Now, why did I gas purse these things? I'll tell you some funny stories, okay? When I first came out with waterproof eyepieces on a very popular user group, I'm not gonna point it out exactly, but there were people making comments like, oh God, waterproof eyepieces. I'm gonna use that the next time I'm observing deep sky objects from the bottom of my swimming pool, okay? And just comments like that. But there was a guy that came out with some very expensive eyepieces. He was out observing all night long just in his backyard, okay? Goes back, crawls into bed. Guess what? It rains, okay? It rains, and it rains hard, all right? The next morning he comes out, he's looking at his open case of eyepieces, It's absolutely soaked. All those eyepieces had to go back for getting taken apart and reassembled. And guess what, folks? It wasn't free. Okay, so that was an expensive lesson. You know, if you don't have waterproof eyepieces, you got to be pretty careful with them. I'm big into educational outreach. Okay, and I want my eyepieces to withstand makeup, peanut butter, cotton candy, spit, whatever, you know, because a lot of people look through them. And a lot of amateurs who do educational outreach and love it won't take their good eyepieces out, okay? Because they know they're going to get abused, okay? Our eyepieces are designed for use, right? Right? So that's part of that. But these eyepieces used at the Yerkes 40-inch, which will reopen soon. It's used at Mount Wilson. It's soon to be used in McDonald Observatory's outreach program.
Ooh, that'd be a good one.
Yeah.
So, okay, guys, I am going to put a stop to the entries because it is going absolutely ballistic right now, Scott. And I've gone past almost 200 entries here.
Wow.
So I'm going to stop the actual thing now. All right, so no more entries below that point that I just posted. No more entries after that post. So you guys can stop spamming it. Of course, there's a delay, so I got 20 more seconds worth of delay to deal with here. So if you want to do the next eyepiece, I need to get a stop-start position. So if you want to do that, I will go from there.
All right. What often is considered our masterpiece eyepieces, though, is the 92-degree series eyepieces. These eyepieces have over 20 millimeters of eye relief. They're still in the hyper-wide class. David Levy, in particular, loves these eyepieces. He so much as said that on video with me, and he especially loves the 12 millimeter. But we have a 12 and a 17, and they're, again, some of my most favorite eyepieces. Fantastic, perfectly sharp to the edge, and tons of eye relief. So if you have astigmatism and you want a hyper wide class with some medium focal lengths that you can use, a focal extender or Barlow lens to magnify even more, you can do that and keep all those wonderful properties. You know, our very, very popular 82-degree series, we've added some long focal length, long eye relief versions of them in a 4.5 and a 6.5 and an 8.5 have joined that series of eyepieces as well. I think they'll love looking through those. I have people that have, you know, I go to star parties and they show me all of their, you know, full sets of 100-degree and their 82-degree and stuff like that. I always feel great about seeing that kind of thing, but I will tell you that the real aspect of getting the best eyepieces is that, you know, it's really a scenario where it's best to try before you buy if you can. That's why you should join astronomy clubs and go to star parties when you can. But there are some attributes such as eye relief that you need to think about, and apparent field and true field of view, contrast, all these things. I made a video that you can see on our website, and maybe at another time Simon wants to get me to come back on air and we can go more into detail about eyepieces. But you can do a lot of homework to narrow in on some focal lengths and stuff, and then you can look at there are other great brands of eyepieces out there. And you know, so I'm not going to say that any one company is the world's best, but there are some very high-end types of eyepieces out there that you should consider. And face it, you know, that getting a best eyepiece to go along with your amazing telescope is that just makes all the visual experience all the more better.
Okay, that was one heck of a count. I counted 207 entries.
What?
So it's a number between 1 and 207. Where would you like to pick?
Or is it just a number? I pick
any number.
A number in my head, you know.
You have a number in your head already?
I did, yeah. Even before we started this, because you said, Scott, I should probably pick a number. whatever, and
So
but
what
now
is
it's
that number?
between 1 and 200 and what?
7.
207.
207.
Okay. All right. So,
No
well,
pressure. No pressure.
no pressure. So I'm going to start with the number 1.
Ooh.
And then we're going to go to 5. And then the last number is 8.
158. Okay, hold on 1 second. So if I go back to my line and type and count 49 backwards.
This is yours.
6, 7, 8, 9, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. I swear to God, if he gets the answer wrong, I'm going to kill him. 41, 42, 43, 44, 45, 46, 47, 48, 49. We actually have a winner.
What?
Yep. Okay. That was a tough one. Okay. So in case you're wondering why I was counting to 49, what I did was minus 158 from 207 and counted from the bottom going back up, because it would have been faster than me counting 157 from one all the way down the other direction. So the winner is Richard Eisenberg. Richard Eisenberg, you are a winner. So I need you to send me your email address, and I will forward this over to Scott Roberts. He will rob you of all of your personal information and probably your credit card. No, I'm just kidding. All your information, and he will get you your prize out to you. Okay, so Richard Eisenberg, I need your email address before the end of Scott's talk, which is in less than 6 minutes, maybe a little bit less. So if we don't see your email address, we just have to throw it back out there.
Oh, wow. Yeah.
So,
okay.
I got a question for you, Scott. Out of all your eyepieces, what actually is the best starting set of eyepieces that you have there?
Well, that's a good question. The starting set for a lot of people, if we didn't think about brands or price or anything like that, I always recommend that people have something like around it between an 8 and a 10 millimeter, 8 to 9 to 10 millimeter. Okay. Because usually as a higher power eyepiece, those eyepieces don't have too short of eye relief. Okay. They typically will work pretty well, even at these higher powers, even during relatively mediocre seeing conditions. Okay. You'll see almost every amateur astronomer that you go out with and you look in their eyepiece case, there's going to be something in that focal length. Okay. Even like a 12, that's the 12-17 would fall into that range. And then I would recommend something that is somewhere between, let's say, 22 and maybe 28 millimeters. Okay. If you tend to fall more into loving to look at deep sky objects, you're going to think about more apparent field. Okay. If you have bad astigmatism in your eye, you're going to want to choose eyepieces that have longer eye relief, maybe as much as like 18 millimeters or longer eye relief. Okay. It kind of limits you in a way. Okay. If you're someone that suffers from that, but you can use focal extenders or Barlow lenses. Now these keep the eye relief for you. They keep the apparent field of the eyepiece for you, but it gives you that extra magnification. So I like to use them. One of the things to look at too is what kind of light pollution do you have? You're going to do, the better astronomer is not how dark a skies you can get to once or twice or 3 or 4 times or maybe even 12 times a year. It's the better astronomer is the astronomer that observes every clear night if they can. Okay. And so a lot of times that means we're observing from the city, from our backyards, from our balconies. Okay. And that's how you train yourself to be better. If you really want to get good, you start drawing what you see at the eyepiece. And so one of my friends, Carlos Hernandez, we did a video about that recently, and he shared some of these things. So it was really interesting. When you draw at the eyepiece and you finish your drawing and then you come back, you find out that you drew features that you might have missed. But it, you know, the eye works like a camera does. You know, it's clocking along at a fractions of a second, and you're building up a visual impression. So we have Mars now coming up towards opposition. This is a great time to try this. Okay, so we got a 9-ish, 20-something-ish, and now you need to drop down to lowest power eyepiece, okay? And so your lowest power eyepiece is going to be based off of exit pupil. And there's lots of ways to calculate exit pupil, but it will have to do with the diameter of the aperture of your telescope and the magnification that you're using, okay? So again, you can get all these formulas online, or you can watch my video on how to calculate all those things, but you want to have a exit pupil that's going to match what your eye will fully dilate to. Now, you can do that by measuring yourself with like hex wrenches that are in the millimeter size format, and see when you can blink out a star, okay? By just holding it up to your cheek, looking up at the star, and then you bring it together. And, you know, as you get close, you'll see that you're splitting the star. And as you get to where it's almost too big, the star just blanks out. So you can kind of calculate what this is all about. A more accurate way to do this is go see your eye doctor. He'll dilate your eyes and he will measure them to the millimeter or the fraction of a millimeter. And I did that once. So
I'm trying to get Richard Eisenberg's email. He did just say something though. It says, "Tell him my purchase is six degree." So
6
yeah, I'm not sure because it's a weird slash over there, but I'm assuming that's what it said, 6 degree. I don't know what to do here at this point because I still haven't gotten his email address, and if he doesn't respond, we're going to have to redo this. Dun, dun, dun. Luckily, I did copy and paste that list of people, so I just got to go through it again, that's all. So hopefully by the time the stream catches up with you, you will give me your email address. Oh, yes, I got it. Woo!
Okay.
Oh, my God, I was getting nervous then. I was getting nervous. Oh, you know what the funniest thing here is?
Sweating.
You should see what his email address is after what you just said.
iDoctor 2020. Great. That's awesome, dude. That's awesome. So.
All right, so we're gonna get you, or well, Scott is gonna get you out this eyepiece. He will email you directly, and we will go from there.
Beautiful.
All right, so we've got Alex McConaughey coming up next. Awesome. We're gonna take a quick break, and when we're back, we're gonna have Alex McConaughey doing Sequence Generator Pro. And Scott, thank you very much for being a part of all of this. I love it when you join in these streams, and you should have heard our banter backwards and forwards when we were, muted, so to speak. This guy's a bucket of fun. If you ever get a chance to meet him at any Star Party event, you just got to sit down and listen to some of his funny stories. He'll tell them. I know, and you've got a lot. That's the funny thing. All right, then. So, Scott, I will see you the next time round, and we will be back in just a moment.
Take care, guys.